Have you ever gazed at the night sky and wondered just how vast the universe might be? A question that has challenged the human mind for centuries and continues to do so even today. When we talk about the size of the universe, we're venturing into a realm that is almost beyond human comprehension. It's like trying to imagine a number larger than infinity, or a color we've never seen. It's not something we can easily wrap our minds around. But let's take a shot at it, shall we? First, let's clarify something. The universe is not static. It's not as if we're living inside a giant cosmic snow globe where everything is fixed in place. Quite the contrary, the universe is dynamic, always in motion, and most importantly, it's expanding. Now, you might be thinking, expanding into what? And that's a great question. But it's also one that doesn't really have a straightforward answer. You see, the universe isn't expanding into anything. Instead, it's all of space itself that is expanding. This means that, with time, the distance between galaxies is increasing. Because of this expansion, it's tough to nail down the actual size of the universe. Imagine trying to measure a balloon while it's being inflated. By the time you've made your measurement, the balloon will have grown larger. In the same way, our universe is constantly growing larger day by day, minute by minute. So, when we talk about the size of the universe, we're really talking about the size of the observable universe. That is, the part of the universe we can actually see from Earth. And even this observable universe is mind-bogglingly large. To give you an idea, the observable universe is estimated to be about 93 billion light-years in diameter. That's a distance so vast that it's almost impossible to truly comprehend. We may not know the exact size of the universe, but we do have an idea of how large the observable universe is, and it's pretty mind-boggling. So, next time you gaze up at the starry expanse, remember, we're just a tiny part of an ever-expanding cosmic landscape. So, what exactly is the observable universe? Now that's a question with layers. The observable universe, quite simply, is the part of the entire universe that we can potentially observe from our little blue planet Earth. You might be wondering, why only a part of the universe? Why not the whole thing? Well, that's because the universe is so vast, so incredibly immense, that light from distant parts hasn't had time to reach us yet, despite traveling at a speed of about 186,000 miles per second. Imagine this: a sphere with Earth at the center, extending outwards in all directions. This sphere represents the observable universe. Now, if you were to measure the diameter of this sphere, from one end to the other, it would be about 93 billion light-years. That's a number so colossal it's almost impossible to comprehend. But what's a light-year, you might ask? Well, a light-year is the distance that light travels in 1 year. And considering light zips through space at a staggering speed of about 186,000 miles every second, you can imagine just how far that is. So, when we say the observable universe is 93 billion light-years in diameter, we're talking about a distance that's beyond human comprehension. But here's the kicker. All this, the stars, galaxies, cosmic dust, and all the other celestial bodies we can see, or rather, that we can potentially observe, they make up only the observable universe. This is just a small, tiny fraction of the entire universe. Yet even this small fraction is teeming with an estimated 2 trillion galaxies, each filled with billions of stars. It's a cosmic spectacle of such grand scale it makes our existence seem both incredibly insignificant and profoundly miraculous at the same time. But remember, the observable universe is just a tiny fraction of the entire universe. And as we continue to explore the cosmos, who knows what new mysteries and wonders await us beyond the veil of the observable universe? If the observable universe is just a fraction, what lies beyond it? This is the question that has been fascinating astronomers and cosmologists for centuries. When we gaze into the night sky, we are only seeing a small slice of the cosmos. The observable universe, the part of the cosmos we can see, is about 93 billion light-years across. But what lies beyond this cosmic horizon? The truth is, we don't know. The universe beyond what we can observe includes regions we cannot yet see or study because light from there hasn't reached us yet. This is due to the universe's constant expansion, a phenomenon that's been taking place since the Big Bang. But just because we can't see it, doesn't mean we can't theorize about it. Based on our understanding of the laws of physics, scientists believe that the universe continues indefinitely, without any edge or boundary. Yet it's not just more of the same. The universe is thought to be filled with galaxies, stars, planets, and possibly even life forms that we cannot even begin to imagine. It's also believed to be filled with dark matter and dark energy, mysterious substances that we are only just beginning to understand. So how do we study something we can't see? Well, we use indirect methods. We look for clues in the cosmic microwave background, the afterglow of the Big Bang. We study the distribution of galaxies and the way they move. And we use computer simulations to make predictions about the structure and composition of the unobservable universe. It's like trying to map an uncharted territory based on a few scattered clues. It's a challenging task, but one that astronomers and cosmologists are eager to undertake. After all, the quest to understand the universe is a journey of discovery that pushes the boundaries of human knowledge and imagination. The size of the entire universe, including these unobservable regions, remains one of the biggest mysteries in cosmology. But as we continue to explore and learn, we get closer to unraveling this cosmic riddle. And who knows what amazing discoveries lie in wait in the vast uncharted territories of the cosmos. Did you know that the universe is expanding at an accelerated rate? That's right, the cosmos isn't static. It's been growing ever since its inception, a mind-boggling event known as the Big Bang. Picture the universe as a balloon inflating, with each speck of dust on its surface moving away from every other speck. In our case, the specks are galaxies, and they're receding from each other as the universe expands. Now, you might be wondering, what's causing this expansion? Well, scientists attribute it to a mysterious force called dark energy. Dark energy is thought to make up about 70% of the universe. And the craziest part? We don't really know what it is. It's called dark, not because it's some kind of cosmic evil, but because it's invisible and frankly, a bit of an enigma. In the early eons following the Big Bang, the universe's expansion was slowing down, much like a ball tossed into the air slows before it starts to fall back down. But then, around 5 billion years ago, something changed. The universe's expansion began to speed up. It's like the ball, instead of falling back down, started to race upward even faster. That's the power of dark energy. It's essentially a cosmic accelerator pedal. It's a common misconception that this expansion is happening within the universe, with galaxies flying away from some central point. But the reality is even stranger. The expansion is happening everywhere, all at once. It's the fabric of space itself that's stretching. This accelerating expansion of the universe is one of the most fascinating discoveries of modern cosmology. It challenges our understanding of the cosmos and drives us to ask more questions. What will the universe look like billions of years from now? Will it keep expanding forever? These are questions that scientists are still trying to answer. This constant, accelerating expansion adds another layer of complexity to determining the universe's size. But it's this very complexity that makes the study of the universe so incredibly fascinating. So, let's keep exploring, shall we? So, given all this, what is our current understanding of the universe's size? Well, let's take a step back and summarize what we've gleaned so far. We've learned that the universe is vast beyond comprehension, spanning an estimated 93 billion light-years in diameter. But remember, that's just the observable universe. This sphere of space that we can see is filled with galaxies, nebulae, stars, and all sorts of celestial wonders. However, the universe extends far beyond what our most powerful telescopes can detect. This unobservable universe, shrouded in mystery, could be infinite for all we know. It's an area of space we've yet to explore, and perhaps may never fully be able to due to the universe's constant expansion. Speaking of expansion, it's not just that the universe is big, it's that it's getting bigger all the time. This isn't a static backdrop on which the cosmic drama unfolds, but a dynamic, ever-evolving entity. As space itself expands, galaxies move away from each other, making the universe not only larger but also more complex to understand. Our current understanding of the universe's size is based on a blend of observation, mathematical models, and theoretical physics. We've come a long way from the ancient belief that Earth was the center of a finite universe. Our perspective has broadened, our knowledge has deepened, and our curiosity has pushed us to ask bigger, tougher questions. The size of the universe is a moving target, one that shifts as we gather more data and refine our theories. It's a testament to the power of scientific inquiry and the human desire to understand our place in the cosmos. We may never have a definitive answer, but the quest for knowledge is a journey, not a destination. While we may never know the exact size of the universe, the journey to discover it is a testament to human curiosity and our drive to understand the world around us.